So good afternoon to everybody. So we are discussing what is a stack, how to implement the stacks. Actually, that's the we are discussing third unit. So we are discussing stacks. So what is a stack? How to implement the stacks? What are the applications? What are the operations? A stack is a linear data structure. It is a last in first out list. So we already know that data structures. There are two types of data structures: linear data structures and non-linear data structures. In linear data structures, where the data is organized linearly, that means sequentially. When the data is organized sequentially, such a list we called as linear data structures. When the data is not organized sequentially, such a list is called as non-linear data structures. A stack is a non-linear linear data structure. That means the data is organized sequentially. It is a last in first out list. A last in first out list is called as stack. Last in first out means the element which is inserted at last will be deleted at first. An element which is inserted at last will be deleted at first. Such a list is called as stacks. In stacks, all insertions and deletions will be done at one end called as top. So all insertions and deletions will be done at one end called as top. So we are always insert the elements at top, and we are always delete the elements from the top. For each element insertion, the top is incremented by 1. For each element deletion, the top is decremented by 1. So whenever we are inserting an element, the top is incremented by 1. Whenever we are deleting an element, the top is decremented by 1. Such a list is called as stacks. So what are the example? For example, suppose initially there is no item. So the first we will insert the top. Then later we can insert one more element. Then we can insert one more element. Always we can insert the elements at top of the position. For each time we can insert the elements at top. This is called as top. Each time we are inserting the elements at top. So this is called as top. Each time we are inserting the elements at top. So each time we are inserting the elements at top of the element. So for each time we are inserting our nodes at top. What are the applications? Where we are using this concept? Implementation of recursion. In recursion, we are using this function. What is recursion? A function which calls the function itself is called as recursion. In recursion, we are using this function. Then evaluation of an expression. What is this? So we know that an expression will contain assignment operators, relational operators like this. So when we are using these stacks, an highest priority operator will be evaluated first, and the lowest priority operator will be evaluated last. In order to implement this, we are using these stacks. Tree traversals, VFS, DF. So we have the different tree traversal algorithms we are using. Graph traversal, infix to postfix. These are all the application steps. So in order to implement these, we must require stacks. So what are the operations that are performed on stacks? We are performing first of all insert push. Push is nothing but to insert an element into the stack. To insert an element, we use push. For each element insertion, the top is incremented by 1. So whenever we are inserting an element, the top is incremented by 1. The stack is full when top greater than or equal to size. When top greater than or equal to size, then the stack is full. So this is called. So top is greater than or equal, stack is full. Otherwise, we are inserting the data into the pop. So pop indicates that to delete an element from the stack. When there is no elements, we cannot delete. So if top equal to -1, actually no means 0, but in arrays we have the 0th location also. That's why we are using -1. Actually, if there is no elements, we call it as 0. Actually, in C language, we have the position, array position starts from 0. That's why we are taken one more least element called as -1. That's why if top equal to -1, stack is empty. Otherwise, we are deleted element from the stack. So we know that we cannot delete the element permanently from the stack. We simply delete an element from the top and we are decrease the top. We can decrease the top value. Useful. This function is used to determine the stack is full or not. The stack is full, so when top greater than or equal to size -1, else stack is not full. Is empty. If top equal to -1, stack is empty, otherwise stack is not empty. Display function is used to print all the elements of the stack. We have the elements from top to 0th position. This is called a stack. Peak. So peak function is you will return the top of the stack. So top of the stack will be called as peak. When there is no element, we cannot return any value. Otherwise, we can return the top of the stack. These are the operations that are performed on stacks. So this concept we are implemented in linked list as well as arrays. So you want to write algorithm in linked list, okay, no problem, we will write. If you want to implement by using arrays, no problem. So sometimes they will ask implementation of stacks by using linked list, implementation of stacks by using arrays. So if you want to implement stacks by using arrays, we can implement. If you want to implement by using linked list, we can implement it. There are different operations. So we have the operations push, pop, is full, is empty, is full, is empty, display. These are so peak we can write. No problem. These are the operations. We can implement these operations by using arrays and as well as linked lists. Implementation, what we are discussed. So that is called as implementation of stacks. So we are implementing the stacks by using arrays. We discuss. Later we can implement by using linked list also, no problem. First we are implementing these operations in stacks. How to implement? We go for this C programming and how to implement in stacks using this. So we require the header files hash include iostream.h, hash include polio.h. We have the iostream.h, polio.h. So we have class stack int top. We have the variable top. Int s is an array, for example. So we define size constant int size equal to 10. So we can store only 10 numbers. Int size we can store only integers only. That's all. We have the public stack top equal to -1. So we are initializing the stack to -1. -1 indicates no elements in the stack. So that's why we are initialize the stack with 0. So we are written initialization is written in constructor because the constructors are invoked automatically whenever it is executed. Then we are using void push. So int data. So void push, void pop, void is full, void is empty, void display, void p. So these are the operations we are using. So these are the methods we are implementing stacks. First of all, these are the prototypes. Push, pop, is full, is empty, display, and pick. These are the functions. Void stack void stack push. So what is how we are inserting? If top greater than or equal to size minus 1, see out, stack is full. If top greater than or equal to top minus 1, stack is full. Otherwise we can insert. For each element insertion, the top is incremented by 1, top plus plus. S of top equal to data. What are the data we want? We can assign soft top. So each time we are assigning the value at the top of the position. This is called as push. The push function is used to insert an element into the stack. When the stack is full, if top greater than or equal to size minus 1, then the stack is full. Otherwise, we can insert the values into the top or stack. For each element insertion, the top is incremented by 1, stack top plus plus stack of top equal to data. Void stack top. This function is used to determine the stack is empty or not. When the stack is empty, if top equal to minus 1, if top equal to minus 1, then the stack is empty, otherwise the stack is not empty. So if top equal to minus 1, we are initialized with minus 1, that's right. If top equal to minus 1, see out stack is empty. Else data equal to stack of top. So we are deleted at top of the stack, that's why. So we are assigned cout pop number deleted. Then we are always top minus. For each element deletion, the top is decremented by 1. Int data equal to stack of top. So then we are displaying the what element we are deleted. For each element deletion, the top is decremented by 1. So whenever we are inserting, the top is incremented by 1. Whenever we are deleting, the top is decremented by 1. Void stack is full. If top greater than or equal to size minus 1, stack is full. If top greater than or equal to size minus 1. Oh, we have that, suppose that we have 10 numbers. So we can store at 9th position only. That's way, if top equal to minus stack minus 1, size minus 1, then the stack is full. Otherwise, the stack is not full, is empty. If top equal to minus 1, else. So if stack is empty, otherwise stack is not empty. Display void stack colon display. This function is used to print the elements of the stack. So the stack is empty, we cannot print the elements, otherwise we can print the elements. If top equal to minus 1, print cout. Stack is empty. Else cout. The stack is for I equal to top, for int I equal to top, I greater than or equal to 0, I minus minus cout s of I. So if top equal to minus 1, stack is empty. There is the stack, we have the stack. So for I equal to top, I greater than or equal to 0, 0, minus 0, I decrement, we are decrementing from top to bottom, we are just with decrementing. So we have the function P, int stack if top equal to minus 1, return 0. Otherwise, return stack of top. These are the different operations. We have the operations. So we have the 6 operations we are implementing. So push, pop, is full, is empty, display, and pick. Push function is used to insert an element into the stack. For each element insertion, the top is incremented by 1 when top equal to minus, we cannot insert the element when top equal to size minus 1. So actually, if the size of the array is 10, we can insert only 9 values, that's why. If top greater than or equal to size minus 1, stack is full, otherwise stack of top is equal to, we can say, pop. So we cannot delete. When we cannot delete if top equal to minus 1, if top equal to minus 1, stack is empty, otherwise we can delete the element stack of data equal to stack of top, and we can delete it. Is full. So when the stack is full, if top is greater than or equal to size minus 1, stack is full, otherwise stack is not full. Is empty. If top equal to minus 1, stack is empty, otherwise stack is not empty. Display. If top equal to minus 1, stack equal to empty, otherwise we can print the elements from top to bottom. Peek function is used to print. These are the operations. Then we go for void main. So we return program int ch choice stack. We have the one array is stack yes ST or something. We written the program through menu-driven programming approach, because whenever we are using multiple operations, it is necessary to implement the program in menu-driven. Otherwise, we cannot. So when there are many numbers, here we have six functions. So whenever we are using multi operations, more than one operation, it is necessary to write the program in menu-driven. Then it's very good. Otherwise, it's not. Do CLR SCR. So one push and C out two pop. C out three is full. C out four is empty. Hello? Hello? Bluetooth. Hello? Ah. Ah. మీరు నువ్వు ఎప్పుడంటే అప్పుడు సెట్రా గుంటూరు వస్తే నేను చేస్తాను ఇంకోరు. సరే వెళ్ళేటప్పుడు రా. అంటే నువ్వు అప్పుడు ఇటు వచ్చేసి వచ్చేటప్పుడు ఫోన్ చేయి నాకు. So we have the operations. So what are the operations we are performing? So sir, peak also is there actually. This 7 is exit. 7 is exit, and we have the operation. One more operation peak. See out. So these are the operations. So switch CH. We have the case 1. If it is 1, we need to push it. So then we have to enter the value C out. Enter the number to be insert. Enter the value to be insert. Same. Suppose we have the data. I will define it in the data. So then we have to call the function st.push data. This is the function. Then I will st.display. I will check it whether the stack is inserted or not. Then we go for break. So st.pop. This is the method to display the function. Then we go for break. Case 3. Push, pop. Then we go for isFull. st.isFull. for break. Case 4. st.is break. Case 5. st.display. Case 6. int k equal to st.p. This is the method to print the values. See out top of stack. So these are the operations. If the stack, if it is 1, we have to insert the value into the stack. That's why enter the value to be inserted. Seen data. So that way data is inserted into the stacks. St.object dot method. So object is the st dot push data. So st.display, then we are displaying the data stack. If it is case 2, so then we are using deleting an element. How the method is called as pop, st.pop and st.display. Is full, st.isFull. Is empty, st.isEmpty. Display, st.object.method name. That's all. So these are the total operations we are performed. Then we have to save it. What is this method? Stacks. Stacks using arrays. So this is the stacks we are using. We have the 2 errors actually. Stack of improper type name. st not stack. We have the variable is s. What is the variable here we are using? S is the variable. Array is s. So that's why s of top. S of top. Yes. S of top. Yes. We have one more error. So semicolon missing. So you have to put the semicolon here. Then again compile it. No errors. Then you have to run the program. So what is push? First of all, enter push 1. Enter your choice. Suppose I will use 6. So the stack is 6. If we have the value is 6. Then you go for enter again. Enter, sorry, deleted. So deleted number is 6. Stack is empty. There is small mistake. I will check it. 7. Okay. So it's empty. Here we just the right. Stack is full. So this actually we have the one element, no, that's why that is the problem. Again we are compiling, running the program. So 1, suppose I want to insert 10 and the value of the stack is 10. Again I will use 1, I inserted 20. So now the stack is 10 and 20. Again I want to insert one more element, 1. Now the stack is 10, 20, that always check it. Always the element is inserted at top position. Suppose I want to insert one more, 1, 40. So we have the above the 30, the new element is inserted. So whenever we are inserting each element, the top is incremented by 1. So now the stack is like this. Suppose I want to delete 2. So what is the deleted number? The deleted number is 40 because we are inserted at top of the stack, 40. So after deletion, the stack is 30, 20, 10. Yes. Actually, before the deletion, the stack is 10, 20, 30, 40. So when we are deleted 40, no, 40 is not in the stack now. So that's why the element is deleted. We are just displaying what element we are deleted. Then we are printing the value. Then we go for 3. Stack is not full. 4. Stack is not empty. 5. So this is the elements where 7. So exit. So this is about implementation. So I will explain once again. So how to implement. So we are implementing the stacks by using arrays. It is possible to implement both arrays and linked list. At present, we are implementing by using arrays. So it is we are using the program we are implementing in C++. So we have the classes and objects. First, I will define the class. So in class, I will define the methods. What are the operations we are performed? That method that will be defined in methods. So we in stacks we always insert the elements at top. That's why int top. Stack of 10, we have the number. Top equal to -1. So stack of top equal to -1. We are initializing the stack with -1. What are the operations we are inserting? Push, pop, is full, is empty, display, and peek. These are the operations we are performing. Push means we are inserting the element into that. So these are the prototypes of the functions we are using in stacks. Somebody will only implementing only 2 or 3, push, pop, and display. Somebody telling only push, pop, and display, it's enough actually. So I am explaining the complete way actually, that's why. So what is push? Push means to insert an element into the stack. So for each element insertion, the top is incremented by 1. Top greater than or equal to size -1, stack is full. So we suppose the size of the stack is 10, we can insert the elements up to 9th position only. That's why if top greater than or equal to size -1, stack is full. Otherwise, we can insert the element into the stacks. For each element insertion, the top is incremented by 1. That's why top plus stack of top equal to data. Stack top minus pop. Pop function is used to delete an element from the stack. If top equal to -1, stack is empty, otherwise stack is not empty. Stack of top equal to top -1. Is full. This function is used to determine the stack is full or not. The stack is full when top equal to, otherwise stack is not. Is empty. If top equal to -1, stack is empty, otherwise stack is not empty. Display function is used to display the values. If top equal to -1, stack is empty, otherwise stack is not empty. So peek function is used to print the values of the stack, and we are implemented the program by using menu driven. So in menu driven approach, first we write what are the methods we are implementing. Actually here we are implementing push, pop, is full, is empty, display, and peek. These are the operations we are performing. So these are the operations. First we have to write then we can call the functions. So if it is 1, how to call the function push and print the value whether the whether the element is inserted into the stack or not. Pop. So this is used to delete from the stack and display yes. Is full, is empty, display, and print. These are the different operations that we are used to implement the stacks. This is about stacks by using arrays. Okay, na? Okay, bye. So good, tomorrow we discuss one more topic, So using linked lists. Today we are discussing so how to implement by using arrays. Tomorrow we discuss how to implement by using linked lists, stacks using linked lists. So this is about implementation of stacks by using arrays. This is the way we are implementing the stacks using arrays. Okay, bye.